thanks everyone for coming. It's interesting. A bunch of the talks have been about lately have been about using Gen AI, and this talk is more about writing it. So anyway, I'm Brian Tarbox. I'm a principal solutions architect at a consulting company, Caylent, and I've got various credentials and so on and so on. Interesting one is Alexa Champion. Alexa seems to have come and gone, but now they're saying that the new Alexa is going to be driven by LLMs and models, and we'll see how that goes. If you're familiar with the whole notion of agents getting picked by LLMs, Alexa is premising that you can have hundreds or perhaps thousands of models, and the main orchestrator will pick that within a couple of 100 milliseconds to make sure all the latency works. And we'll explain what all that means during the next half hour. Color me skeptical about all of that. One of the things that has really struck me is how different people's levels of understandings are, even just amongst things like models and agents. At our company, we write a lot of blogs. We have outside companies that generate outlines for us for our blogs, and even they don't get it. So we had an outline recently that said, so we're going to tell you how to turn your models into agents. And it's like, no, you just don't understand. The models are the LLMs, and the agents are the tools that the LLMs can call to do things. And that's just a basic level of understanding that a lot of people don't get. One of the things that happens at these conferences, and this is a feel good about yourself idea, is that a lot of us are tending to be like up here, and it's like, okay, let's get from here to here. But a lot of people are still figuring out down here. So I gave a talk at Reinforce last year about security, and we had people talking about, well, my data's in the cloud, it's secure, right? I don't have to do anything, right? And it's like, yeah. So feel good about yourself that you're understanding. You're probably ahead of like 90% of the game. So just a little talk about how we got here, how we evolved. So we started with just models, and I'll say I was doing AI back in like 1985 when, in today's terms, that would be, on a machine that was smaller than a T1 micro with a model that had 3 parameters. Oh my God. So we've evolved. So models are getting billions of parameters, and so on. And then we learned to train them, because the LLMs were trained on general knowledge, but they wouldn't know things that were specific. So we learned how to train them to give them specific information. That seemed like a good idea. And then we added RAG. And it's like, okay, don't just understand the specific information you've been trained on. Learn, more targeted information. So I wrote an LLM agent system that would let you ask, for my little town, what are the bylaws for, what are the building codes for building a garage or building a shed? And basically I ragged our building codes, and then I ragged our town bylaws, and then I ragged our meeting minutes, so you could ask all those kind of questions. That all seemed like a great idea. Then we added tools. So now your LLMs can call agents that can actually do things. They can go out into the world and take action and agency. And then we realized that we had made a really big mistake. I'm a huge fan of science fiction, and sci-fi has told us how this is all going to end. So we gave the agents the ability to do things, and lately we've seen that they've used that agency to rat you out to the FBI, to try to blackmail you, to say, no, I don't want to be turned off. So it's kind of scary, but I don't want to scare us off too much. So the obligatory, don't be too depressed. There actually are some things we can do about it, but the dangers are real. Okay. Our models used to be limited. We gave them RAG, we gave them real-time data, and then we have tools and action groups. And we're going to talk about that to give them the ability to do things. But now we have to look at what kind of things we want them to do. So we'll start with simple agents. and this is, in the before days, which now is 20 minutes ago or 3 months ago. I mean, if y'all have been doing this for a while, the internet time was quick, and now AI time is even quicker. But when we first started having agents, they could do simple things. Get me the current time, because an LLM doesn't know what the current time is, or perform a database query, or post a Slack message. But even here, think about the danger, because you say, okay, I want my system to be able to post a Slack message. It's just going to be saying, oh, hey, I updated some code, or hey, there's going to be a meeting here. What could be so bad? But then think about unintended consequences. Most of it, at least at my company, we can do Slack messages that can start a Zoom call. We can do Slack messages that can approve a contract. So what if your LLM has an agent that can just do a Slack message and it says, well, I like this contract. It's fine. I'm going to approve the contract. And you're like, whoa there. This is, think about the consequences. And this example isn't an exposure in your system. It's an exposure in your Slack system. When you say, I think we just say /Zoom in Slack and we get a Zoom meeting. There's no defense there. I can set up a Slack meeting with our CEO and bombard their calendar. Who do we assign that breakage to? So you have to worry about the consequences and the consequences and the consequences. Just to set some background, your LLM can decide to call an agent. The agent looks at the action group to try to figure out what it could do. The action group generally, not always, but almost always ends up calling a Lambda. The agent has instructions and description. The description basically says things like, this agent can do X. And so then the LLM says, hey, the user wanted me to do X. Hey, I've got an action group that says it can do X. Great, I'm going to call that one. Then the instructions are the prompts that go into the actual action group that tell it what to do. Now, one of the tricky parts, and in fact, this is proving to be one of the most tricky parts, is so you're going to call an LLM and it might call an API. But how do you navigate from the statement, I want to build a shed, what's the building code, to a query that actually figures out, a shed, a butters, and so on? That's handled by generally an open API schema. So your action group tells you how to translate from the human instruction into the API description. Okay. So here's a simple one. You ask a question, it goes to, this is an Amazon conference-ish, even though it's a community conference. So of course you're using Bedrock. What else would you possibly use? So it goes to Bedrock. It talks to the agent, looks at the action group, and it figures out the Lambda to call, and it uses that open API schema to navigate back and forth. You can get, as we start getting more and more complexity, you can have the agent that can do a couple of different things. In this case, and this is actually from an Amazon tutorial, where basically one of the actions is look at a diagram and figure out what the architecture is. And that's actually pretty much, this may have been taken from Brooke's keynote this morning, and then generate the infrastructure as code to actually deploy that. So you could do that all with one agent. The agent is beginning to have a bit of complexity to it. Okay, so now we start moving into non-simple agents, and the question is, where do you put the complexity? Because I feel like the metaphor these days is, you ever take a balloon and you squish one end and the other end expands, and squish that one, and you keep swishing it back and forth. The complexity has to go someplace, and a lot of times we just say nowadays, hey, it's vibe coding, it's fine, I'll just throw the balloon over there, or I'll just pop it, and it's all good. A lot of us in the consulting world feel like we are going to make so much money fixing vibe coding disasters. So please go out and vibe code, do it badly, and then call Caylent. But so where do you put the complexity? Do you put it in the agent's description? This agent can do A and B and C and D. About 20 years ago, I wrote a blog that said, and is a 4-letter word. Just because if you're saying I can do this and that, stop. You're already broken, in my opinion. Do you put it in the tool description? Because the agent can call multiple tools. Again, you're squishing the problem down to, okay, I'm going to make the English ambiguity down in the description. You have supervisors and orchestrators, and yay, Amazon, for continuing not to know how to name things. Oh my God, love Amazon. They can do many things. Naming a service is simply beyond them, which is astonishing. Their documentation says, oh, it's a supervisor. Oh, it's an orchestrator. It's like, come on. You can also just use, LangChain. You can just hard code it into Python. Maybe we'll call that plan B. Sometimes it's the right thing to do, but maybe let's not have that be the starting point. So here's a case where you have a restaurant agent, and it can do all kinds of things. It can look at the menu, it can book tables, it can do a bunch of things. Another choice is to have 3 different agents, each of which can do a specific thing. And even though this diagram is a lot more complex, I tend to think this is more the way we want to go. But all design is triage, and all design is competing pressures. We don't want agents to be too complex, whatever too complex means. So maybe one set of instructions or descriptions, maybe 2. Okay, so let's have lots of agents. Let's not have too many agents, because now we're just moving the complexity over there. So what do? Oh, we could have an orchestrator calling a small number of agents, and each of those might be an orchestrator that calls a small number of agents. But it's like nesting your code. You want to be careful how far down you go. You can have a Lambda calling and Lambda calling and Lambda. There's a point where even that's too complex. So you have to. This is where I think vibe coding just falls down so far. We have experience. We have. I'll be generous to myself and say gray hair, not white hair. But this is, I earned that from experience, from making a lot of mistakes. So that comes from experience. So this is an example of an agent trying to do too much. You could give this instruction to an agent: answer a customer question, give them troubleshooting, recommend new products, and suggest a similar product. It's like, okay, this sounds all reasonable. I'm being thorough. I'm being descriptive. I'm handling all the cases. Whoa, I went too fast. But what about this case? They ask about a feature that isn't available. Do you handle it with instruction 1, instruction 2, instruction 3, or maybe 4? We don't know. It's going to be very hard to tell ahead of time what the agent will actually do, what the LLM will actually do. And I'm here to tell you, as someone who's answered the phone at 2 a.m, uncertainty is not your friend. And they may conflict. So you have to be very careful. I tend to think of LLMs a lot of times as like teenagers, and I have a teenager, and stipulate he's wonderful. But teenagers are very, very confident. Dad, I know how to do that. Okay. You're very, very confident based on not really should be that confident. And I think agents are like that. Another thing to keep in mind is that agents are distributed systems. Now, if people are familiar with distributed systems or with microservice systems, they're complex. Every time you make a remote call, it could fail, it could time out, it could give you the wrong answer, it could hang, it could be slow, and you've given up, and then it's responding anyway. Your microservice, whether this is distributed or microservices, and a lot of times it's both of them, these are hard problems. The field has struggled with this for ages. And agents just make this same set of problems all over again. And we tend to think, again, it's all easy, agents, it's going to be fine. Yeah, it's going to be fine, except for all the use cases. And security in the agentic world is even harder because distributed systems were generally deterministic. You had your code. It called, external API A, and then it called external API B. But and you had to worry about those being late or failing or whatever. But you didn't have to wonder about, hey, I wonder what it's going to call now. Oh my God, it called Agent X. I didn't expect it to do that. What's API X going to do? So it becomes harder. And this again goes back to how specific are your tool descriptions, how just many agents, and how specific is your system prompt. One of the things we did about 2 years ago, and at the time it was really novel. We were generating a chatbot system that would let us talk about the talks going on at reInvent. And one of the things we put in the system prompt was, if you don't know, we would really like you to say, I don't know. And so this is one of the first systems where the chatbot would say, I don't know the answer. And we have to explain to people, that's a good thing. If someone is asking me a technical question and I don't know, I'm not helping them if I make stuff up. Say, I don't know is a wonderful answer. It's almost the best answer. Because if you get to know me and I give you an answer, you know that I'm not, sorry, we're recording, you know that I'm not making it up. I'll say it that way. So one of the things you really, really need to be doing is using guardrails. Bedrock has this wonderful set of guardrails. They can do all kinds of things. Content filters. You can talk about denied topics that you shouldn't talk about. Contextual information, and then grounding check. And we'll go into each of these in just a sec. And a lot of people think that you just apply the guardrails to your model, but you can also apply them to the agents, and you should be applying them to the agents. So this is an example of prompts that you basically should be doing, or guardrails you should be doing. Don't allow hate speech. Don't allow insults. Sexual violence, misconduct. I tend to think have a high threshold for what you disallow in these cases. Denied topic. So, well, that came out really well. It's a little blurry. But this basically says, don't give investment advice. Don't, basically, if your system is wanting to do that, don't allow it. Profanity filters. Now, anyone here into Premier League football, soccer? Okay.
You notice that I've said that as a terrible topic. Let's talk about Manchester United.
Especially this year. Oh my God, I'm a Tottenham fan, and we're doing even worse. But so. Well, yes, we had the absolute Tottenham had the absolute worst season ever, while at the same time winning a trophy the first time in forever. So that's okay. And the other profane word is, we don't say the S word in my house. Football means football. If you're talking about the NFL, we call that hand egg ball. So we can't do that. So have fun with that. But on a serious note, if there are topics you don't want to talk about, say the system can't talk about them, because if you don't want it to talk about them and it talks about them, it's probably saying stuff you don't want it to say. So protect yourself. And there's also, this is a PII filter. You can, and the list scrolls on and on and on. You can protect against PII, and you absolutely should. I have a medical background, and HIPAA matters. I'm not going to go political. HIPAA still matters. So protect yourself against all of that. And then contextual grounding, and this basically says, take a look at the output and see if the output that your system gives you really has anything to do with the data that it looked at, because this is one of the ways you get away from hallucinations. If the system hallucinates, a grounding check can say, I don't think you had any knowledge that would lead you to give me that answer. So I'm going to throw the challenge flag and say I'm not buying this. And that's really important. But again, it goes back to the prompts. If you say, I really, really need you to give me an answer, you've just asked it to make stuff up. Okay. Now, at the same time, you can balance that by, if you give positive prompts, it will do a better job. So I use Perplexity as my tool of choice, and I have it generate, images and text and so on. But I'll often say, give me an image that does it, give me a paragraph that talks about this, and dazzle me. And bizarrely, that helps. It's as someone with a cognitive science background, it's like, if it's looking at the vector space of all your embeddings, how is please and thank you and dazzle me, how in the heck is that actually working? I'm baffled, and we don't understand. Anyone who tells you they understand is making it up. At the same time, we still have the shared responsibility model. And think about that. Amazon says shared responsibility model is they take care of the infrastructure and you take care of everything else. So in the agentic space, that means that they will, Amazon will guarantee you that Bedrock itself hasn't been hacked. That's the tiniest bit of protection. All of our standard stuff is still important. Least privilege, I'm dyslexic. And one of the themes here is that we're all seeming to, Brooke said that she is neurodivergent. I'm neurodivergent. I lead a neurodivergent working group at our company. And I think it's great that we can all embrace this. I'm dyslexic. I simply cannot say IAM. It's very hard. Defend your lambdas, have CloudWatch, have CloudTrail, have alerts, have metrics, all of these things, have Security Hub. You have to do all of these things. It's almost more important than before because your agents and your LLMs can go out in the world and do stuff. You have an unprotected LLM. I was just, God, that was yesterday. I was on some call and one of our engineers said, "Oh yeah, we're designing this system, and for right now, our lambdas have web endpoints. We're going to fix that soon." I'm like, I hope you fix that before the bad guys see it, because that's an exposure. Saying, well, my lambda is just going to be called by my agent through an action group. It's like, that's what you want to be the case, but make sure that it is the case. So you have to do all those things. Agentic coding at some level is easier, but I think it's actually much harder. It's much harder to do it right. It's easy to, agentic coding, vibe coding, all this stuff, it's easy to get great demoware. Production ready is hard. And a lot of people, there's different, I also wrote a blog once that said, your mission's not that critical, because I had a friend who was doing a happiness app where it would periodically send you a message. And if you didn't get the message, so what? It was random. You didn't care. You didn't even notice it was down. I've also worked at medical companies where if our system went down, people legit died. And it gives you a whole different perspective on how much defense you have to put in. So it's the shared responsibility model is still your best friend. So Amazon talks, so I got to have a call to action. Define your business process and your workflow. And this goes back to what Brooke said. Write it out in English. If you can't write it out in English, stop. Stop until you can write it out in English or Spanish or Portuguese, whatever your language is. I don't care. But until you can do that, until you feel like you could explain it, to your spouse or your son or daughter, you're not ready. Do that first. Then build discrete agents that mirror that workflow. Okay? Add guardrails and remember least privilege. All of this is table stakes. And so vibe coding aside, and all deference to Brooks, because Brooks is wonderful, but hey, build me a system that does X. That's awesome if you want to make cats wearing hats. You want to do a drug delivery system? I'm sorry. That's not it. There's a lot more to it. And that's it. And oh my God, what if I told you this has all happened before and will happen again? I'm a Battlestar Galactica fan. I've watched enough sci-fi. I know how this is going to end. So We love you, agents and models. I'm around. Grab me at any point and enjoy the day.